Hello guys, welcome back. If you are new to my channel, please do like, share, comment and subscribe. So today we are going to study about the atom. So in 1804, a scientist named Dalton, first of all we should know that what is the history of the atom, right? So Dalton was a scientist who proposed that the atom is the smallest particle. But it's a human nature. We are not going to easily convinced what we know and what we just said. So after this Dalton, a scientist named called J.J. Thomson, who performed the CRT tube, cathode ray tube experiment in around 1896 and discovered electron. In my other video, we will see detail about this one. Then after that, Rutherford, he came into the existence and he performed the famous gold foil experiment in which he bombarded the gold foil with the alpha particles and discovered proton. Then there is a one more scientist came, name is Chadwick, who is going to discover about the neutron. So in this way, my atom is distributed in three parts, that is electron, proton and neutron. So basically, this is the history of the atom. For more detail, you can visit my other videos. Now here we are going to focus completely on the atomic structure. The electron, proton and the neutron is there. So atom was divided into three subparticles, that is called as the electron, the proton as the neutron. The electron is negative in charge, whereas the proton is positive in charge and neutron is zero in the charge. So it was proposed that, I mean, they performed the experiment. So when they performed the experiment, they had seen the electrons is going to the positive part of the battery, whereas the protons are going to the negative part of the battery. So the charge, the actual charge, and there is a one relative charge, right? So the actual charge, here I'm writing. So everybody knows about this charge that opposite attract each other and like repel each other. So the actual charge of electron is what? It is negative 1.6 into 10 raised to power minus 19 coulomb. This C is the unit of a charge. In physics or chemistry, it's very important when we write the parameter, we should write the SI units also. The proton charge is positive 1.6 into 10 raised to power minus 19 coulomb. As you can see, they both are in the same numbers, but only difference is what? One is negative and one is positive, right? Here I'm writing the relative mass. So relative mass means, or relative charge, sorry. So relative charge. So here I'm going to write the relative charge. So relative charge is what? In respect of one. So it was considered the electron, one electron has a negative shown charge and one proton has a positive one charge. Same way for the mass also. So there is the actual mass. For this mass spectrometer is going to be conducted and all kind of things are there. A lot of more experiment which is in the AS level and the A level. So when you reach over there, you are going to see about that thing or all. This is purposely for that IGAC and the GCAC and the AQA people. Actual mass, and there is a one more word, relative mass. Since the electrons are very small, so the electron mass is considered as a 9.11 into 10 raised to power minus 31 kg, whereas the proton mass and the neutron mass is going to consider as an 1.6 into 10 raised to power minus 27 kg and 1.609 into 10 raised to power minus 27 kg. Now, with respect of electron, when we are finding this is relative mass is 1, this is also 1, and this is 1 over 1855, or somewhere you had seen 1840. So as you can see, the mass of the electron is much smaller than the mass of the proton and the neutron. That's why for considering the mass number, we are not going to consider the electron. We are just going to consider the neutron and the proton. Right? Now, how to represent an atom? Suppose this X. X means anything, right? In the mathematics, we know X means anything. So here also, because we have 108 elements in the periodic table, so we just take it as an X, which represent this the metal or non-metal or elements name. You can say elements name. There is a Z and there is a A. This Z represent number of proton. Somebody is also saying atomic number, right? And this A represent the mass number. So before that, we should know the structure of an atom. So in the structure of atom, when the Rutherford performed the experiment, he said that the center of nucleus, all of the proton is in the center of a nucleus and it has a positive charge and the electrons are somewhere here. Then after that, this Neil Neil Bohr, he came and he discovered that electrons are moving around the nucleus in a orbits. So there are orbits. So first orbit name is K shell, and it can contain only and only two electrons. It's like a one BHK where only two-person can sit or can stay, right? Then after that K shell, there is a L shell. The maximum number of electron that it accumulate is 8, right? And after that, then there is a M and N. They can also accumulate 8 and 8 electrons. So in this way, now how to find the number of electron, how to find the number of proton, what is the mass of the neutron, how much is the number of a neutron, how to find and all that we are going to see, right? So take an example of a sodium. Everybody note that the sodium is represented as an N. And this is the structure that you're going to find in a periodic table. As you can see, this is a smaller one. Always keep in mind, the smaller number is your atomic number. So this is my number of proton, right? And this is my mass number. Clear, guys? Now here, what we have to do, how we are going to find it. The atom is in two states. One is called as the neutral state and one is called as the charge state. Basically, we are calling ion state. It can be positive, it can be negative, that we will discuss it later. So right now we are going to focus on the neutral state. So on the neutral state, what is the condition? That my number of proton must be equal to number of electron. This is the condition. When it become neutral, when they have the zero charge, right? So how many plus you have and how many minus you have, if they both are equal, so one plus is going to cancel by the one minus, and in this way I got in charge of a neutral on my atom. Now let's see how to find it. Take the example of what I say, carbon, right? You know why carbon is famous and why carbon is my favorite? Because everything is carbon, right? The thing we eat, the thing we breathe, the thing we use, whether it's a lubricant, diesel, petrol, oil, furniture, cosmetics, clothes, food, everything contain the carbon. So take the example of the carbon. So as you can see, C, 12 and 6. So this 12, this represented your mass number and this represented my number of proton. So as I say that in the neutral state, the number of proton is equal to number of electron. So don't you think so? They both are 6. Now, this mass number is what? Is a sum of a neutron and the proton. I will use the abbreviation. For electron, I will write E. For the proton, I will write P. And for the neutron, I will write N. So this mass number is how much? Neutron plus proton. Now look, this is maths, okay? So here, how much is the mass number? My mass number is 12. How much is the number of proton? The number of proton is 6. So I can find a neutron by 12 minus 6 and I got a 6. So luckily here, neutron, electron and proton all are 6, right? So in this way, you can find the number of electron, proton and the neutron. Let's take an example of aluminum, right? So aluminum belong to the group 3 or 13 of the periodic table, and it has 13 atomic number or number of proton and 27 mass number. So what is my mass number here? This is 27 and number of proton is 12, 13. So as we know in the neutral state, the proton and the electron both are equal. So it must be 13 and the mass number is what? Neutron plus proton. So here 27 equal to neutron plus 13 and neutron will be 27 minus 13, that will get 14. So in this way you can find the number of neutron, proton and the electron, right? So as we know, this proton is going to reside. Let's draw the example, draw the electronic structure. Now we are going to discuss about the places of the electron. So there is a 13 proton and 40 neutron. So this 13 proton and the 40 neutron is going to stay in the nucleus. Since the neutron does not have any charge, so the nucleus will contain the positive charge. As I told you, there are four orbits, K, L, M, and N. Here the number of electron is how much? 13, right? Okay. So the maximum number of electron that they can accumulate is 2, 8, 8, and 8. Now we are going to decide their fate, how they are going to stay. So 13, right? I took 2 out. How much is left? 11. So 2 will come here. Now this 11. Now as we can see, so K orbit is filled by the 2 electron. Now we can see L. L is how much L can take? 8. Since I have 11, so I can subtract minus 8 here. So it becomes 3, right? Here it comes 8. Now, how much the M? Now go back to the next orbit, that is the M. How much M can take? M can take maximum up to 8. This means it can go below 8, not above 8. So now I have a 3 electron. There is no more that I can subtract. So 3 will be there. So as you can see, 2, 8, and 3. And this is the electronic configuration of aluminum. That is K orbit, L orbit, M orbit, 2, 8, and 3. Now, if we have to draw it, so what we are going to do, here I make the K orbit, right? Since the K contains 2 electrons, so I put 2 electrons, then L. It contains 8 electrons, 1, 2, 3, 4, 5, 6, 7, 8. And there are again the M. So 1, 2, and 3. You can put anywhere. There is nothing like that I have to put. So in this way, we are going to do it, that the configuration of a atomic structure and all. So in this way, we are going to do it like this. Now let's suppose we have like a fluorine. So fluorine is 19 and there is a 9. So first of all, I will write how many electron, how many neutron, and how many proton. So since proton is 9, as you can see, in the neutral state, the electron is also 9 and the neutron will be 19 minus 9, that is equal to 10. So in this way, you can write it, right? Now 9 electron, use the octet rule, 2, 8, 8, and 8. So first 2 gone, so 7 left, right? 9 minus 2. So 7 left, so 7 will go to the next orbit. So K contain 2 and L contains 7. And if I have to draw the structure, it will be simply this, and 2 orbits, right? So 1, 2, 1, 2, 3, 4, 5, 6, and 7. And this way we can represent the fluorine. Let's take one more example. Should we take potassium, K? So K is 39 and 19, right? Same way, write it, electron, proton, and neutron. So since proton is 19, so neutral state, electron will be also 19 and neutron will be 13 minus 19, that is 20, right? Now go for that division for the electrons. So first will contain 2. So 19 minus 2. How much left? 17. The second can contain maximum 8. We have a scope to subtract the 8. So minus 8, here is a 9, right? The third will also contain 8. So minus 8, there is a 1. So look here, this is the orbit. So this is my K, this is my L, this is my M, and this is my N. Now, if I have to draw the structure, how I'm going to draw it, I'll make a nucleus here, right? K, L, as you can see, all the four orbits are there, M, and N, right? And then I'm going to put, so first orbit will contain 2 electron, the second will contain 8, then 1, again 8, and then lastly it's a 1. So in this way, we can represent, here we can write KLMN 2881. So this is the electronic configuration. So in this way, we are going to draw about the electronic structure of any of the atom, especially till group 20, this atomic mass till 20, you can draw it. So you can make a, for learning, you can make a table like this, select H1, here is helium 42, then lithium 5,3, then beryllium 7,4, then boron 11 and 5, carbon 12,6, nitrogen 14 and 7, oxygen, you can find it from the periodic table, 16 and 8, fluorine 19 and 9, neon 20 and 10, sodium 23 and 11, magnesium 24 and 12, and here aluminum your 27 and 13. I'm going to take only this much is there, the rest of the thing you can see it from the periodic table. So what I'm going to do, I'm going to make a EP, and here I will take it as a PE, P pen, right? It's easy to remember. So how many proton? 1. How many electron? 1. Since neutron is 0, because 1 minus 1 will give you the 0. So it will go to the k orbit, right? How many proton? 2. Electron 2. And neutron is 4 minus 2, that is your 2. Now this 2 again go to the k orbit, because k can take maximum 2, right? Now go for the lithium. So here is a 3. So this is also 3. And this will be your 5 minus 3, that is equal to 2. Now here, look, division is started. So k can take 2, so 1 is left, so 1 will go to the L. So k has 2 and L has 1. Then come for the beryllium, 4. This is also 4, and this will be 7 minus 4, that is the 3. Now here 4, k will go to the 2, L will be also 2. Here this is 5, this is 5. So k is your 2, L is your 3, and this is your 6. This is 6, this is 6, K is your 2, L is your 4. This is your 6. Then 7, 7, K is your 2, L is your 5. And here is also 7. This is your 8, 8, K is your 2, L is your 6, and this is also 8. This is 9, this is 9, and this is 10. So here K and here L. So it becomes 7, it becomes 2. This is 10, this is 10, and this is also 10. So K is your 2, L is your 8. Now look at here, guys, as we are following the, when the K orbit is completely filled, right? Then only I jump to the L orbit. Now L can contain maximum 8. So as you can see, 1, then it increasing by 2, then 3, then 4, then 5, then 6, then 7, and then 8. Now the next electron, whatever it will come, it will go to the next orbit. So here sodium has 11, right? This is also 11, and this is your 23 minus 11, that is 12. So here K is 2 because it is filled, then L is 8, and then M will introduce and now 1. So in this way, it is going to be done. And in this way, our group and the periods are divided. The group which is ended with a number electron 1 is belong to the group 1. The number ended with the 2 belong to the group 2. Same way, number ended with the 5 belong to the group 5. And please mind it, this is very much important because through this you can decide the valence electron, the valency, and making the compounds, then the balancing the equation, everything will be there. So keep this in your mind very carefully. So this is group 7, this is group 8 or 18, and group 8 is a noble gas configuration. Everybody want to achieve it. When we want to eat, we are eating whole, right? We are not eating half stomach and all. We want to eat full stomach, right? Same way. So the orbit, they want to full their self, either by losing or gaining. That we are going to discuss in the next class. So this is all about the atomic structure. I hope you understand. If you have any doubt, any issue, please drop your comment in the comment box. And if you do like it, please share, subscribe, and just share with your friends and do subscribe the channel. Thank you so much. That's all for the atomic structure. Bye bye.